Good evening, friends. Today we are discussing on formulating LPP. So for the given statement, how to write the linear programming problem and how to solve the problem which is formulated using graphical method. Now the problem statement goes like this. A firm manufactures two types of products A and B and sells them at a profit of 5 rupees on type A and 3 rupees on type B. In the sense, by selling 1 unit of product A, we are getting a profit of 5 rupees, and selling 1 unit of product B, we are getting 3 rupees profit. So each product is processed on two machines M1 and M2. So the two products A and B are processed on the two machines M1 and M2, and the condition given is that the type A product requires 1 minute of processing time on machine 1 and 2 minutes of time on machine 2. So that given constraint is tabulated here. So 1 unit of product A requires 1 minute of time on machine 1 and 2 minutes of time on machine 2, and the type B product requires 1 minute on machine 1 and 1 minute on machine 2. So that is tabulated here. So 1 unit of product B requires 1 minute of time on machine 1 and 1 minute of time on machine 2. And it is also said that the machines M1 and M2 are respectively available for at most 5 hours and 6 hours during any working day. That means machine 1 is freely available for 5 hours. So in the sense, 1 hour is 60 minutes. So 5 hour means 60 into 5. So that is 300 minutes here. Similarly, machine 2 is freely available for 6 hours. So 1 hour 60 minutes. So 6 hour means 60 into 6. So that is 360. So availability of machines M1 and M2. So that is 300 minutes and 360 minutes. So it is asked to find out how many units of each type of product should the firm has to produce a day in order to maximize the profit. By selling more and more units of product, so my profit will be maximized. So it is asked to formulate the problem as LPP and solve graphically. Now we will start the solution like this. Let X will be the units of product A produced and Y will be the units of product B produced. That means the number of units of product A produced will be X and number of units of product B produced will be Y. Number of products cannot be negative. So X comma Y greater than or equal to 0. If I don't produce any product, my X and Y value can take 0. If I produce some products of A and B, X and Y will take positive value. Number of products cannot be negative. So one of the constraint is X comma Y greater than or equal to 0. Now the constraints is on availability of machine. So the availability of machine M1, whether I process product A or product B, right? So for 1 unit of product A, so it takes 1 minute of time, and 1 unit of product B will spend for 1 minute of 1 unit of product B. So if I produce X number of units of product A, so the time taken on machine 1 will be 1 into X, and if I produce Y units of product B, so that is 1 into Y. So for 1 unit of product B, so the time spent is 1 minute. For Y units of product, it is 1 into Y. So the constraint is now 1x plus 1y, and maximum time available on the machine 1 is only 300 minutes. So less than or equal to constraint. Similarly on machine 2. So whether I produce product A or product B. So the number of minutes available on machine 2 is only 360 minutes. So if I produce 1 unit of product A, so the time spent is 2 minutes. So from product A, so the total time spent is 2 into x. So that is 2x. Then if I produce 1 unit of product B, the time spent on machine 2 is 1 minute. So for y number of units, so the time spent is 1 into y. So totally it is 2 into x plus 1 into y. So that is less than or equal to 360 minutes. Now the firm manufactures two types of products A and B and selling them at a profit of, okay, it is given that 5 rupees profit for 1 unit of type A and 3 rupees profit on 1 unit of type B product. So therefore if I produce X number of units of product A, so I am getting the profit of 5 into X from product A. Similarly 1 unit of B gives me the profit of 3 rupees. So by selling Y units of product B, I am getting the profit of 3y. So total profit I am getting is Z is equal to 5x plus 3y to be maximized. Thus the mathematical function of LPP, the mathematical formulation of LPP is maximize Z is equal to 5x plus 3y, and we have the constraints 1x plus 1y less than or equal to 300 and 2x plus 1y less than or equal to 360 and x comma y greater than or equal to 0. So this is the formulation of LPP. Now I need to find out how many number of products A will be produced, that is X, and how many number of products B will be produced, so as that this Z objective function is to be maximized. So for this I am plotting the graph like this. Okay, so the first equation is 1x plus 1y is less than or equal to 300. So that equation is taken. So that is x plus y is equal to 300. So by making x as 0, the y value will take 300. By making y as 0, the x value will be taken as 300. So on x axis, so I am taking the point, so that is 300. On y axis, I am taking the point 300. In the sense, for this constraint, that is x plus y is equal to 300. So my x value is 300, my y value is 300. So on x axis taking 300 and y value taking 300, joining the line. So that is having the constraint, so less than or equal to. So the area I have to consider for this constraint is less than or equal to. So I have to take the area below this line. So the next constraint is 2x plus y is less than or equal to 360. So 2x plus y is equal to 360. So if I make y is equal to 0, x value will take 180. So I am taking 180 on x axis. Then if I make x as 0, y value will take 360. So on y axis I am marking 360. So then joining this 180 and 360, I am getting a line. So the constraint is here is less than or equal to. So I have to consider the area below this line. If I have greater than or equal to constraint, then I have to take the area above this line. Now, for both the lines, the constraints are less than or equal to only. So the feasible region is the one which is hatched here. Darkened area is my feasible region. Then I have to consider all the corner points. So this origin O is also one of the corner points with the coordinates 0, 0. Then I have B1. So with the coordinates 0, 300. So that is the point B1 here. X coordinate is 0, y coordinate is 300. Then I have the corner point, so that is E1, measure x coordinate and y coordinate. I am getting 60, 240. Then the last corner point is this C1 with the coordinates x coordinate 180, y coordinate is 0. Then the values of Z for these corner points. So the origin O with 0, 0, by substituting x and y as 0, I am getting Z value as 0. Then for point B1, so the coordinates are 0, 300. X is 0, y coordinate is 300. Sorry. So substituting x and y as 0 and 300 respectively, I am getting Z value as 900. Then taking the point C1 with the coordinates 180, 0, substitute x and y here. I am getting C1 as 900 and E1. So with the coordinates 60, 240, substituting x and y as 60 and 240, I am getting Z value is 1020. Out of these four values, the maximum value of Z is 1020, which is attained at point E1 with the coordinates 60, 240. So 60 units of product A and 240 units of product B will be produced to get a maximum profit of rupees 1020. Thank you.